Good morning, ladies and gentlemen. Today we're going to continue working with moles and quantities, but we're going to begin putting a focus on percent composition. Now, composition by itself simply means what things are made up of. So then percent composition, what that's referring to is how much of something is out of a total. So that's a percentage means part of a whole. That's what percent means intuitively. So what we're going to start working with is trying to determine percentage by mass. And you have, when you're talking about percentages, you have to specify by what, because there's percentage by mass and then there's percentage by volume. Percentage by volume is how much space something takes up. But just because something takes up more space doesn't necessarily mean it has more mass. All right. Percent composition is used to identify unknown substances in the world of chemistry. Let's say we know that it has carbon and hydrogen in it, but we don't know how many of each. Percent composition can help us figure that out if we have certain pieces of information. Okay. So intuitively, I'm sure you guys know how percentages work already. So in this case, you have potassium chromate and potassium dichromate, and they have a little pie chart showing you percentages by mass. So in potassium chromate, you have two potassiums, you have one chromium, and you have four oxygens. And so the two potassiums make up 40% of the weight. The chromium is 27%, and the oxygen makes up 33%. And the dichromate, the percentages change up a little bit because now you have more chromiums and more oxygens. The oxygen percentage jumps up, and the chromium percentage jumps up, and the potassium percentage goes down. So percentages are just part of a whole, okay? So what we're going to be doing today is trying to figure out exactly this. What percentage of certain elements make up certain molecules? To find the percentage of something, you need to take its contribution divided by the total, okay? So in this case, you need to take the number of atoms that element has in that molecule. For example, in the potassium chromate, you have two potassiums, so you need to double the weight. You take the number of atoms, multiply it by the atomic mass, and then divide that by the total weight of the molecule, okay? And then that'll give you the percentage. You can multiply it by 100 to give you the percentage. So here's an example of ethane. Ethane is a common gas used in combustion. You have two carbons and you have six hydrogens, okay? So let's say we're trying to find the percentage of carbon. First thing you need is how many atoms of carbon do you have? We have two atoms of carbon, so a 2 goes there. What is the atomic mass of carbon? It is 12. If you don't remember to find that, again, you can always go to P table and it tells you carbon has an atomic mass of 12. And then what is the total? Well, to figure out the total, you got to know the hydrogen too. So you have two carbons, they're both 12. You have six hydrogens. Hydrogens are 1, okay? So that comes out to be 24 plus 6, which gives you 30. So this whole thing, the whole thing is 30, okay? And that's where the 30 ends up on the bottom, okay? The whole thing is 30. If you want to find the piece of it that's just carbon, you need the 2 times the 12 and divide that by the 30, and you end up getting 80%, okay? And then the hydrogen ends up being, you have 6 hydrogens, 1 each, divide that by the total, which is 30, and you get 20%, okay? So the big thing to notice here is that even though you have more hydrogens than you do carbons, you have 6 hydrogens, only 2 carbons, carbon makes up more of the mass. You have less carbons, but each carbon weighs more, okay? Significantly more than the hydrogen does, okay? So you have less carbon, but it makes up most of the mass, okay? So by mass, percentage by mass, carbon is 80% of the mass, and the hydrogen is only 20% of the mass, okay? And they give you an alternate calculation. Another way you could have found the hydrogen percentage, once we figured out the carbon percentage, there's only two elements. There's carbon and there's hydrogen. So once you know one of them, you can automatically figure out the other one. All you have to do is subtract the 80 from the 100, and you end up getting 20%. Okay, so that's another way you could have found the hydrogen percentage. Once you find one, you can find the other. Okay, but that's how percentage by mass works. Okay, so we're still on the FN example. Hydrogen was 20%, carbon was 80%. Even though you had more hydrogens than carbon, that does not matter. It's the mass that matters. And now let's do some examples. In water, which is H2O, which element is going to account for more of the mass, the hydrogen or the oxygen? Firstly, let's figure out the total. Okay, hydrogen again is 1, oxygen is 16. Okay, so we have one oxygen is 16, and then we have 2 hydrogens, and each hydrogen is 1. So this gives us 18 total. So the total atomic mass of water is 18. 16 of it comes from oxygen, and 2 of it comes from hydrogen. Which one provides more mass? The answer would be the oxygen. The oxygen gives you 16. The hydrogen only gives you 2. Okay? So oxygen accounts for more of the mass. And now we can actually, let's calculate the number. Okay? What is the percentage of mass of oxygen in water? So remember the percentage, it's the number of atoms times the atomic mass. You have 1 oxygen atom and it weighs 16 divided by the total. The total is 18. So then you plug into your calculator 16 divided by 18 and you can get your final answer. Off the top of my head, I do not know what that answer is. I forget. I can't do that calculation in my head. That would be what? That's 8 over 9. I mean, it's going to be less than 90. I would say, I believe it's B if I'm doing the calculation correct in my, because 9 out of 10 would be 90. It's going to be a little less than that. I'm thinking it's B. But plug into your calculator 16 divided by 18 and you will get your final answer. What is the percentage by mass of carbon and acetone? Okay, this one, we have 3 elements this time. We have carbon, hydrogen, and oxygen. First thing we need to figure out, let's figure out the total. Carbon gives you 12. Carbon is 12, and we have 3 of them. Okay, we have 3 of them. Hydrogen gives you 1, but we have 6 of them. And oxygen again gives you 16, and we only have 1 of them. Okay, so this ends up being 36 plus 6. 36 plus 6 is 42. And then 42 plus 16 gives you 58. Okay, so our total is 58. Okay, again, this is 36 plus 6 is 42. 42 plus 16 is 58. So we have a 58 total. We want to know the mass of just carbon. So we want to know the percentage carbon. We need the carbon mass. Again, you need the number of units or the number of atoms. You have 3 carbon atoms. Each carbon atom is 12. And then you divide that by the total, which is 58. Okay. And the top is going to end up being 36. You put that into your calculator again, you will get an answer. Let me grab my calculator just so we can get this done. Okay. If you plug this into your calculator, you should get 62%. Okay, so the answer here is B. And that's enough examples with the percentages. That's how you do the percentage by mass. For 71, you do the same thing. Find the total, and then divide the BA mass by the total. And in 72, you would do the same thing. Okay, to answer the true or false question. Same idea. Okay. So that is percent composition. That is what you're going to end up doing for today's assignment. Today you're going to be doing the percent composition section. And all it entails is finding total masses and then trying to figure out percentages by figuring out the certain parts. Okay. I'm going to do 31, 32, and 33. And we'll, from there, think we'll be done. What time? Where are we on time right now? 10 minutes. Okay. So this is a little on the shorter end, which is good. So 31 says, what is the percentage by mass of water and a sample of calcium chloride hexahydrate? Okay. So what is a hydrate in the first place? Okay. So before we move on, I want to explain what a hydrate is because they don't ever talk about it in the slides. This is a hydrate. A hydrate is just a molecule that has water attached to it. Okay. So here you have calcium sulfate. Okay. This is calcium sulfate dihydrate. Okay. It's dihydrate because you have two water molecules attached to it. Okay. So all a hydrate is just a chemical that has water attached to it. So calcium chloride hexahydrate is calcium chloride with water attached to it. Okay. So remember calcium, this will be +2. So this will be CaCl2 with 6 waters attached. So calcium chloride hexahydrate would be CaCl2 with 6 waters connected to it. That's all a hydrate is. And we want to know what percentage of the total mass is the water. So we need to figure out the total mass of this thing first. Okay. So the mass of the water, let's figure out the mass of the water. Water is 18 total. 16 from the oxygen, and you get 2 from the hydrogen. So one single water is 18. Okay? One single water is 18. I think we have blank space at the bottom. Okay? Let me do this down here since we have blank space. Okay? So again, CaCl2 with 6 waters. Okay. So the water mass would be 6 times 18. That's the water mass. Okay. And then the calcium chloride, calcium is what? Calcium, we're going to round that to 40. So this would be 40 plus. And then the chlorine, I'm going to round it to 35 and a half. And then you have 2 of them, so you need to double it. Okay. So this comes out to be what? This is 35 plus 30, 70. This would be 71. 71 plus 40 would be 111. Okay, so this is 111. This is 60. 60 plus 48 gives you 108. You add them, your total comes out to be 100, 200, 210, 219. So your total mass is 219. We want to find the percentage that is water. And so to do that, you just need to now plug in the 108 from the water divided by the 219. So your final answer is going to be 108 divided by 219. Why is this your final answer? Again, what are we looking for? 31 asks us to find the percentage of mass of the water in the sample. We found the total from the water. The total from the water is 108. The total for the entire thing is 219. You need to take the water mass and divide it by the total, which would be 108 divided by 219. This will give you your final answer. Okay. That is the final answer for number 31. Okay. Now let's do number 32. 32, we want to know the percentage of mass of oxygen in a sample of iron 3 nitrate. Okay. Iron 3 nitrate. Okay. Give me a sec here. I'll be right back. I gotta handle something. And we are back. My apologies. Okay. So we want to find the percentage of mass of oxygen in a sample of iron 3 nitrate. First thing we need to do is remember what this is. Okay. Iron 3 nitrate. This is where the past work starts to come up. You got to remember how to figure out these molecules. Fe NO3 3. This is what iron 3 nitrate would end up being. We need to figure out what the total mass of this is. Okay. So iron is what? Fe 55 point. I'm gonna call that 55.8. That's 55.8. Okay. Okay. Plus nitrogen. Nitrogen is 14, and we only have one of them. Okay. There's only one iron. There's only one nitrogen. I'm sorry. There's not. There's not one nitrogen. I'm sorry. There's one iron. There are 3 nitrogens. Okay. There are 3 nitrogens. You have 3 of the entire NO3, and each NO3 only has 1 nitrogen. So we have 3 nitrogens total. Plus oxygen gives 16, and we have 9 of them. Okay, where does the 9 come from? Again, we have 3 NO3s, and each NO3 brings 3 oxygens. So it's 9 oxygens total. So this is our total for the entire thing. Okay, it's 55.8 plus 14 times 3 plus 16 times 9. Okay, this I cannot do in my head, so I will not bother. 55.8 plus 14 times 3 plus 16 times 9. Okay, the total comes out to be 200. Oops, I got to scroll down a little bit. I'm running out of space. Total comes out to be 241.8. This is our total. Okay, this is our total. We want to figure out the percentage that is just oxygen. Okay, what piece of this is the oxygen? This is the oxygen piece. So to figure out the percentage of oxygen, you need to do 16 times 9 and divide that by your total. And if you do that, you end up getting about 59.55%. Okay, that is your percentage, 59.55%. If you plug that into your calculator. That is number 32. That is the percentage by mass, specifically of oxygen in iron 3 nitrate. Okay. Again, we found the total first. After you find the total, you divide the piece that you want the percentage of by the total, and that'll give you your final answer. That's number 32. And then 33 is a little unique. So now we're combining, we're doing one of those two-step problems that I told you about before. It's telling us the percentage by mass of something already. It says we have 40% calcium by mass. We want to know how many atoms of calcium that is if we have 20 grams of it, okay? So number 33 is asking us how many atoms. That's what we're looking for. Our final answer is not going to be in moles. It's not going to be in mass. Our final answer is going to be in atoms, okay? So we need to figure that out. What do we know? We know that the sample is 40% calcium. And how much mass do we have? We have 20 grams. So in order to answer this question, number 33, first thing we need to figure out is how much calcium we have, okay? We have 20 grams total. We have 20 grams total, okay? And that's what we got from the problem. Out of those 20 grams, 40% of it is calcium. If you know the percentage, if you know the percentage in the total, you can figure out how much of it you have, okay? So then the calcium mass then is going to be equal to the total times the percentage, okay? It's 40% times 20. And 40% as a decimal is 0.4, okay? I'm expecting you guys to know that already. 40% as a decimal is 0.4. So then you do 0.4 times 20, and you will get your total calcium mass, okay? So out of those 20 grams, this comes out to be 8 grams of calcium, okay? So we have 8 grams of calcium. That is what we know for a fact, okay? We have 8 grams of calcium. I'm going to erase this because I need the space. Now that we figured that out. 8 grams of Ca. We are not done yet because the answer we're looking for is atoms. But in order for us to figure out how many atoms we have, we need to figure out how many moles we have first, okay? So when we're working with mass, you have to remember that moles is equal to mass divided by molar mass. Remember that equation? N is equal to little m divided by big M. The little m is the mass. We have 8. The big M is the molar mass. Remember, the molar mass is the same as the atomic mass. So then go to the periodic table. You see that calcium is 40. Okay, I'm going to round that to 40.1. 40.07, I'm going to round it to 40.1. Okay. You plug this into your calculator and you get how many moles of calcium you have. Okay. So 8 divided by 40.1 comes out to be, I'm going to round this to 0.2. We have 0.2 moles. Okay, this is moles of calcium. Okay. Okay. So 0.2 moles of calcium. I'm going to erase this again because I need the space. And so we just figured out that 8 grams of calcium is equal to 0.2 moles of calcium. This is what we have right now. And now that we have the moles, we can answer the question. We want to know how many atoms of calcium we have. Remember, the first equation we learned was the one with Avogadro's number. Remember where it was little n is equal to big N divided by Na. Big N is the number of atoms, which is what we're looking for. Na is Avogadro's number, and then N is the little n is the number of moles. We want to find big N, so you need to rearrange it, and you get N is equal to little n times Na. So then our answer, N, is going to be equal to little n, which is 0.2. That's what we calculated with the moles, times Avogadro's number. Avogadro's number is 6.02 times 10 to the 23. Okay? You plug that into your calculator and you will get your final answer. Okay? 0.2 times 6.02 times 10 to the 23. You plug that into your calculator, you will get your final answer for the number of atoms of calcium that you have. Okay? And that is how you do number 33. Okay? That is it for today, ladies and gentlemen. You can do the rest of your problems. If you have any questions or concerns, as always, please feel free to reach out. I wish you all the best. Take care. Have a happy Monday.